Welcome to Lab 8 of CE371. This is our final lab of the semester. The lab procedure instruction outlined here will allow for the determination of the in situ density of soil near the ground surface using the sand cone method. In this lab, the value of the unit weight of the clean sand used will be provided. In practice, determination of the unit weight of the sand may be required. During the lab, pay special attention to the valve on the sand cone to be sure it is open or closed as required. Step 1 of the unit weight of the in situ soil. We're going to place the aluminum plate on the ground surface at our chosen location. We're going to excavate an area around the plate and below the plate, approximately to a depth of 3 inches. Ultimately, what we want to do is create a nice flat surface that the plate can be attached to at a depth of 3 inches. As we excavate out the soil, we want to place this off to the side. We're not going to use that in our test, but we do want to keep it intact so that we can put it back in after we're done with our test. Particularly that includes the sod. If there's any sod you can pull up and lay off to the side, please be sure to do that. Now that we've got a nice flat surface, we can secure the base plate to the ground using the nails that are provided. There should be 4 nails in the bucket provided to you, as well as a hammer. The nails will simply just hold the plate in place for the duration of the test. Now we want to weigh the empty paint can provided. At this point, go ahead and remove the lid, place it off to the side. We want to make sure that the can itself is completely empty. There's no soil in there from prior years. You've got a scale included. Make sure you've zeroed out that scale, and then go ahead and weigh and record the weight of the empty paint can. At this point, we're going to use the small shovel provided, and we're going to excavate a hole down into the ground through the hole in the base plate. The amount of soil we want to remove is roughly equal to somewhere in the neighborhood of 1/2 of the volume of the paint can. Now it's critically important that all the soil removed from the hole ends up in the paint can. So please take your time with this step so that we're not dropping any soil in the transfer from the ground over to the can. It does not need to be perfectly circular. It doesn't need to be perfectly flat at the base either. We're simply excavating out a volume of soil that will be determined later on. And again, we're going to continue this excavation down until our paint can is roughly 1/2 full. We want to make sure that any soil that's been loosened up in the excavation process that's simply laying here in the base of the hole is removed and placed into the paint can. It's best to do that by hand. And again, anything that may have ended up on the sides, try to get that into the paint can as well. So at this point, now we can weigh the paint can again with the soil in the can. Make sure you record that. Clearly the difference between the first weight of the can and the second weight of the can is going to be equal to the weight of the soil we've removed from the hole. That's going to be a critical part to our step in determining what is the unit weight of the soil. At this point, we can place this paint can off to the side, and it's important to go ahead and put the lid on nice and loose, but get the lid on there because otherwise we're losing moisture. And we're going to determine moisture content later on as part of the test. We don't want to lose moisture any further at this point. Now, we want to weigh the sand cone apparatus. The sand cone apparatus includes this reservoir of sand, the funnel, and this is the valve portion. We're going to place that on our scale, record the original weight, and again, that's the weight of the apparatus plus the sand that's inside the reservoir. With the valve closed, we want to go ahead and invert the sand cone apparatus and place it onto the plate. We want to absolutely make sure we understand which way the valve is open and which way the valve is closed. If we look, typically there's a line placed on the side to show you when it is closed, or you can visually look down inside the funnel, and turning the brass knob on the side, we can see when it's open and when it's closed. Make sure you understand which is open and which is closed, because it can throw off the results of this test. So with the valve closed now, we can invert the entire apparatus and place it down on top of the base plate. The base plate has a circle on there, a small indentation where that funnel should drop in perfectly. Now at this point, with the apparatus inverted, we can open up the valve, turning it to its open position, and what it's doing is sand is running out of the reservoir. It's filling up the excavation below, but it's also filling up the volume associated with this funnel. What we want to do is we want to give it sufficient time for the sand to run through there. One trick to make sure that the sand has completely filled up both the excavation and the funnel is to place your ear down next to the can and listen carefully. You can hear the sand moving through the system. I can tell you right now, this one is not done. I can still hear sand moving through there. So we're going to give that just a minute to go ahead and for the sand to fill up again the excavation and the funnel. When we're done with this, we're going to then close up that valve, remove the sand cone apparatus. As we do, there will be some sand that was inside the funnel that should spread out and fall away. That's no problem. But we're then going to take that sand cone apparatus, place it back onto the scale, record a new weight, and the difference in the sand cone apparatus weight from the initial to the final is clearly the weight of the sand placed into the funnel and into the excavation. If we know the unit weight of the sand, that's weight per volume, and we just determine how much weight of sand was required, we can back calculate what's the volume of sand we placed into the hole, as well as the volume of sand used in the funnel. Now the funnel itself is marked with a volume on the side. We want to subtract out that volume from the volume of sand we've used to fill up the hole plus the funnel, which will leave us with just the volume of the sand placed into the excavation. Now previously we determined what was the weight of the soil taken out of the excavation. Knowing that plus the volume of the excavation allows us to determine the unit weight of the soil in place in a moist condition. So based on what I'm hearing, it sounds like that has stopped. I'm going to close off the valve. I'm going to double check it's in the closed position. And as I lift this up and away, you see that the sand kind of drops away. Again, no big deal at this point. We've already determined, or we've already taken out all the sand out of the apparatus we need to. Place it back on the scale, get the new weight, subtract the two, determine the weight of the sand required, or the weight of the sand required to fill the hole, the excavation, as well as the funnel. So at this point, we've determined everything we need to come up with the moist unit weight of the in-situ soil. The next step in the process is the moisture content determination. We've done this many times in CE371 this semester, but we've done it in a lab using tear cans. We don't have an oven and we don't have a tear can here, so instead what we're going to use is a simple system here with a frying pan and a camp stove. Now the frying pan becomes our tear can. So we want to determine what's the empty weight of the frying pan. Place that on our scale, make sure it's completely clean initially. Record that information. We're going to open up our paint can again, so at this point we can remove the lid. We're going to place 3 heaping spoons rather, of soil into the frying pan. Now ultimately we're going to start cooking this soil to cook off the moisture. So to avoid any possible explosions, we're going to go ahead and remove any rocks, anything at the gravel size or above, as well as if there's any organics in there's no reason to determine those. They will burn off. So we don't need the organics, we don't need the rocks, and if there's any earthworms, it's probably a good idea to let those go as well. So now we're going to place the frying pan with the soil back onto the scale, determine that weight, the difference between the two. Now at this point, is our moist weight of the soil in the frying pan. You're going to light your cook stove. If you need assistance with that, please let us know, but there should be a lighter in your bin as well as a gas canister. Once your cook stove is up and running, we're going to place the frying pan onto the cook stove, and with a clean spoon, the intent is to move the soil around in the frying pan until we cook off all the moisture. You'll notice that the soil will take on a dull coloration to it, indicating that the moisture has been removed. There should be a consistent coloration throughout. You'll want to call over either the lab technicians or one of the instructors to take a look at it to help you determine if all the moisture has been removed. If the moisture has been removed and we've confirmed that, again, we reweigh the weight of the soil with the frying pan. Now the difference between those two numbers, of course, is the amount of moisture we removed from the soil. At this point, we've got all the information we need to back calculate the moisture content for the in-place soil. You'll need to use a phase diagram to complete that calculation. Now, with the dry unit weight of the soil and the moisture content, we can actually plot that data onto a Proctor curve. Plotting that onto a Proctor curve and utilizing a specification block as identified in the lab handout will allow you to tell the contractor whether the in-place density of the soil is sufficient to meet the specification. Ultimately, you need to call in that information to the contractor today. Your contractor, in this case, is actually your CE371 instructor. You've got their office phone number. You want to place a phone call to them and leave a voice message on their office phone. Be sure to identify who you are, what project you're calling with regards to, what the results are, and then if there's a recommendation that needs to be made to the contractor relative to making in-place adjustments, make sure you've clearly identified what those recommendations are. That should complete everything for Lab 8 of CE371. Have fun.